Hey everyone, my name is Olmstead. I'm a data scientist here at DataRobot, and today I'm going to show you a demo of our platform focusing on four main areas that are going to save you a ton of time on pretty much any data science project that you might be working on. So first of all, we have the DataRobot AI catalog, which is part of the platform that allows you to collect, manage, organize, and even prepare data for your machine learning project. So we'll be focusing on this, as well as a brand new capability in DataRobot for data pipelining. This is a feature that allows you to automate data engineering workflows so that you've got the right data for your projects, both for training and at prediction time, which is super important, big time saver there. Also, we'll be taking a look at basically the flagship feature in DataRobot, which is our AutoML engine. We're going to be learning about the DataRobot Leaderboard here and all of the model transparency and interpretability features that we have. And then finally, we're going to be taking a look at DataRobot ML Ops. So DataRobot ML Ops is really all about helping you get those models into production where you can monitor and manage them. So with that, what I would like to do is kick into our demo here. And what I'm going to do is start by talking about the use case that I'm going to be showing today. And, one thing that I'm really obsessed with almost outside of work is real estate analytics. I'm sure, if you guys have been kind of following the real estate market over the last few months, it's really interesting. Well, one of the things that's tricky, whether you're buying or selling a home, is getting the price right? So estimating the value of a property. If you're buying a home, you don't want to pay too much. If you're selling your home, you certainly don't want to list it for too much more than it's worth, or else you just won't get the bids. You won't get the attention that the property deserves. And so, in fact, what we're going to do today is we're going to look at a real estate example. So I mentioned that we're going to jump into something called the DataRobot AI catalog. So again, the AI catalog is a place where we can connect to different data sources. In fact, there's a really great library of connections that we have in the platform. So if you've got data in, say, Google BigQuery or in Redshift or in Snowflake, we've got all kinds of connectors built in to help you get data from wherever it is. And in today's example, I'm going to be working with a data set that contains house listings. So this is not a huge data set by any standards. It's only about 6,000 rows. It's got 30 columns. What we're looking at here in the AI catalog is some metadata about the data set that we're going to work with here. And within the catalog, we can also get like a quick profile of the data. So in this quick profile of the data, what we have are basically a list of all of the different columns that we've got in our data set. So again, each row here represents a listing on the MLS. So here's a listing. The property was built in 2017. There's information like, hey, the number of bedrooms and bathrooms that are in this place, the square footage, of course, where it's located on the map in terms of its latitude and longitude. So the thing that's really tricky with this particular data set, let's say if we wanted to estimate what the price was going to be, the information at our disposal includes not just like structured information, like the beds and baths and square footage, but we have unstructured things like images. And notice that for some properties, we have a photo of the exterior of the home pretty much on every row, but for the kitchen image, sometimes we're missing images. That's something that might be tricky to deal with. Also, you can see that there's a column here called description, where in some of the records, we have a description of exactly what this property is like. This is like where the real estate agent or the seller will kind of describe what the home is like, hitting on that X factor, what really differentiates the property. Ultimately, what we want to do in today's demonstration is we want to basically have a machine learning model learn from all of these different attributes in order to tell us the value of the property. That way, if I'm going to go out and make real estate investing decisions, I'll know if I'm getting a good deal. If I'm trying to sell my property, I'll be able to list my property at the right price. Now, before I dive into the nuts and bolts of actually creating the DataRobot project, there's a couple of things that I want to show you. One of the things that I want to talk about is actually a brand new feature in DataRobot that allows you to build data pipelines. So oftentimes we're faced with the problem that our data might live in different places. You may have data in the cloud in a storage bucket, some other data in a relational database, or just a CSV file on your computer, and you kind of need to bring these together, or set up some pipeline of transformation steps in order to actually set up your machine learning data set. Now, new in the product is the ability to actually schedule these data transformation steps. So in fact, in this simple example here, I've got a Spark SQL query that is basically querying data against some database connection that I've set up in the AI catalog. We're basically running this query and then outputting the result back into the AI catalog. So what's really important about this is the fact that you can schedule these, and you can also call these pipelines at prediction time. So it's very important that when you prepare a data set for machine learning, that all of those feature engineering steps, all those transformations that you do to prepare that data set, that those things are reproducible when you actually want to make a prediction about how much your home is worth, right? So this is something that is new and a major time saver when you're actually operationalizing your models. All right. Next, what we're going to do is actually launch into the machine learning project. So I'm going to go ahead and click on the Create Project button, and I'm going to pass this data set into DataRobot, where we can actually start building some predictive models here. Great. And so once that data set has been ingested into DataRobot, we can scroll down and basically explore the data set that has been ingested here. And so whether you're pulling that data in from the AI catalog, or you're just starting from scratch with some CSV file on your desktop, what DataRobot is going to do is some quick inspection of the data set. And here what you can see is that DataRobot has found that there is location information, right? So in this real estate use case, knowing the location of the property and the value of nearby homes is going to be really, really important when we're trying to estimate the value of a property. And so basically, if I click on this drop-down menu here, you'll notice that there's a couple of things, a couple of different features that DataRobot could use. There's something called zip geometry. So this is basically a column that delineates the zip code where the property is located. This column here called geometry is basically a DataRobot engineered feature where it has combined latitude and longitude into a point on the map, and it can basically find little clusters of properties for which it will engineer lagged features. Scrolling down a little bit further here, all of the columns that we were inspecting earlier have basically just been ingested. We've just detected things like the data type, performed some quick descriptive statistics for all of the columns in our data set, looking for potential data quality problems as well. So if I hover over this little warning for year built, you can see that there are some potential outliers in this column. Up at the top, a quick summary of data quality problems across the data set here. So outliers in 8 of our columns. Also, I want to call out the different data quality checks that DataRobot is doing here. Some of the ones that we're bringing to the forefront is a check for disguised missing values, columns that might have excessive zeros, or one that I think is particularly useful is this concept of inliers. Inliers are data points that might be similar across many values, but have essentially a value in a column that doesn't make sense given its other values. So this is something that can be really useful in detecting problematic records that you might want to exclude. I'm going to dismiss the warning for now. And if we scroll down a little bit further, ultimately what we want to do in today's exercise is we want to predict what a house is going to be worth. And so this is the distribution of our target. One thing that's also happening here is because we have that geospatial information, DataRobot is going to allow us to plot our properties on a map. So here we have it. Each one of these points represents one of the properties from our data set. Now, of course, the real magic is not just being able to see the properties on the map here, but having DataRobot's AutoML engine perform some geospatial analysis, meaning that it's going to automatically identify clusters, automatically identify neighborhoods, and for each one of these groups will calculate things like the average price in that area. This is one thing that DataRobot is doing. Another thing that I think is really powerful is the automatic handling of image data that we've got in this data set. So here, for example, we've got all of the exterior images of our homes. Now, some of these homes you can see are maybe a lower value property. We've also got examples of these beautiful mansions here, which surely will have a higher value. DataRobot will basically learn that a home that looks like this will fetch a higher value than a home probably that looks like this one, but we'll see, of course. All right, excellent. So what we're going to do next is basically tell DataRobot what we're trying to predict, which of course is the price. We're going to set this as our target. Once that's done, basically the DataRobot autopilot engine is ready for action. We can basically go ahead and hit start, and DataRobot will get to work. There are a ton of other advanced features that we could discuss for the project setup, but for the sake of time, we're going to go ahead and launch it into autopilot. Autopilot will take a little while to run. Basically, what's going to happen here is we are essentially doing a deeper analysis of this data set. We are going to basically rank all of the features in this data set from being most predictive to least predictive. This is going to inform DataRobot's blueprint generation step, okay, where DataRobot will design algorithms to solve this problem. In other words, it will design algorithms that can predict price. What do I mean by design algorithms? Well, DataRobot has a collection of pre-processing steps that it's going to use, things like standardizing our target, performing transfer learning on those images, doing that geospatial analysis, searching for differences, ratios, and other data pre-processing steps, in addition to testing out different regression models like neural networks, boosted trees, and other models with the goal of predicting price. This data set is rather complex in terms of having lots of different image features and those geospatial features. It takes a little while for this data set to run, but what I have done, again, for the sake of time here, is I have run this in advance, and we now have a completed leaderboard. The leaderboard is a rank-ordered list of all of the different algorithms that DataRobot has come up with and tested for solving this problem. At the top of the leaderboard here, you can see the current leader, the model that has been tested on out-of-sample data and has been selected for deployment. In order to get this far, in order to land on a final model here, DataRobot has tried 158 different alternative approaches to solving this problem. These approaches include sophisticated techniques like model blending. This is where DataRobot has actually combined multiple algorithms into a single blueprint in order to maximize the accuracy. Let's take a closer look at the model that's currently in the lead here. This is an extreme gradient boosted tree regressor that also incorporates some unsupervised learning. Let's take a more detailed look. If we actually go ahead and click on the leader on the board here, it reveals what we call the blueprint. This is a diagram that shows exactly what DataRobot is doing under the covers in order to get to its final prediction. And as you can see, there's a complex web of steps that involve taking that raw data set that we loaded and preparing the data for the final step of actually fitting this XGBoost model. So, really all of the steps that you see in this web represent something that normally a data scientist might do using Python or R. Let's take a closer look here. So some of the data that we loaded into this data set was basically unstructured text, right? So we had something, we had some unstructured text representing the description of the property. This is where the real estate agent or the seller would type up a little description explaining, oh yeah, great property with a view and a pool, blah, blah, blah. So what DataRobot is doing here is it is applying a text mining step. Basically a step here that is going to extract words from that unstructured text and turn those words into numbers that can be interpreted by our final machine learning algorithm. Again, these are things that each one of these blocks represents, a step that a data scientist would normally have to try by hand. But what DataRobot has done here is it has detected that text column and has automatically applied the text transforms that need to happen before you use that text with an algorithm like XGBoost. All right, let's take a closer look at that geospatial column, right? So remember, we had latitude and longitude for every single property. Well, in order to get some value out of knowing where the property is, what DataRobot is doing is it's turning that latitude and longitude into a point on a map, like we saw a few moments ago, and then applying this next step that we call a spatial neighborhood featurizer. This is a proprietary DataRobot step where, again, basically what we're doing is using some KNN algorithm to basically detect little neighborhoods, basically little clusters on the map. And for each of those little pockets of homes, we're calculating some additional features, such as, what is the average price for that neighborhood, and then using that value as another feature for our final prediction. All right. So again, each one of these blocks represents some set of steps that you would normally want to experiment with. DataRobot has basically assembled 158 of these different flows, of these different experiments that that it has tried, and this is the one that resulted in the best accuracy. Let's take a quick look at what DataRobot is doing with our images. Right. So we had a photograph of the kitchen and the exterior of the home. DataRobot has included with the product these pre-trained neural networks. All right, so SqueezeNet, for example, is a pre-trained neural network that has already seen millions of photos. It's already been trained on photos of, trains, planes, cats, dogs, people, you name it. It's able to look at photos and it can recognize things in the photos. It can recognize if there are important features in that photograph. Basically, what we're doing here is we are extracting those important features from the photograph and then binding those weights, those features, as a new set of things that our final machine learning model can actually learn from. This is a process called transfer learning, and because we are leveraging pre-trained neural networks here, we can get to a very good model in a lot less time without relying on really expensive hardware like GPUs. This project was run completely using CPUs, which are, of course, much less expensive to run, and it allows us to get to a great model in a lot less time without having to train these neural networks up from scratch, from the ground up. So huge time saver there. And again, for those who are interested in sort of diving deeper into the settings for this whole blueprint, you can jump into the advanced tuning area where, as an advanced user, you could go ahead and actually change out the pre-trained neural network that's being used there, right? So instead of using SqueezeNet, you could go ahead and manually select one of these different options in here and basically rerun the algorithm and see if another pre-trained neural network does a better job. Another thing that we're very proud of at DataRobot here is that all of the models that we run in this leaderboard can be explained, meaning that in addition to providing you with that diagram, that blueprint that shows how the model works, we can also show you how the model performs. So there's a great number of visualizations that help us compare how the model performs on out-of-sample tests. And so this plot here is basically showing us the model's prediction of price versus what the homes actually ended up selling for. So if I hover the mouse over this first bin here, what you can see is that, well, I know it's hard to tell, but there's actually two lines, right? There's a blue line and an orange line. The blue line is the model prediction, and the orange line represents the actual selling price of homes in this group. So this represents 116 homes where DataRobot's prediction was low. And when DataRobot's prediction is low, 125,000, the actual value in this group is also low, 127,000. So this model is doing a pretty good job of estimating the homes on the lower end of the scale. And as I kind of go across this line here, you can see that as the model's average price increases a little bit, so too does the actual selling price. And this particular model does a really great job all the way up until these fairly expensive $700,000 homes. It's not until we get into the uber expensive multi-million-dollar homes that the model becomes a little bit less reliable here. And I would venture to guess is because homes in this category, the super expensive, include features that are simply just not described in this data set. But that's okay. Other things that we have to analyze the model performance is like the residual plot. So again, just another way of looking at the actual versus prediction. Residual distribution plot that's showing us that, again, most of our error hovers around 0, indicating that this in general the model's residuals are not that great, which is good. That's exactly what we want to see. Now, in addition to showing us how the model is performing with respect to accuracy, we can also show exactly what is driving the model's predictions. The feature impact plot reveals what matters most to the model. And as a data scientist, this is important because when I want to improve the model's accuracy, these are the features that I want to look at. All right, so square footage is the most important feature to this model, meaning that if I had a home and I didn't know what its square footage was, well, you can bet that the model is not going to be as accurate in that case. The way that this is rendered is that basically we get the model to make a whole bunch of predictions where we know what the answer is, and as the model is making predictions, we remove the information from this column by basically injecting a bunch of noise, and then we measure how much worse the model's predictions are, how much the accuracy decays. And when we do this to the square footage column, it impacts the model accuracy the most. Okay. The next feature on the list is something called zip geometry. So this is basically information that describes the boundary of the zip code. That is a very important piece of information for this model, followed by essentially the size of the lot, the acres, right? And then, of course, the location itself. So geometry, again, remember, this is a DataRobot computed feature that also includes additional derived information, such as the average price for a region on the map. All right, this is one of the most important features in this data set, and this is one of the DataRobot derived features. Another indicator that we're getting here is that bathrooms is redundant. Okay, so it's telling us that, hey, bathrooms and square footage are providing very similar information about the value of the home. And for this particular model, essentially, this is telling us that, hey, you know what, you could probably not even include bathrooms in this data set, and it might actually, in fact, excluding bathrooms from the data set may actually even increase the model's accuracy. So that's something that we could experiment with. All right. Now, another thing that keeps me up at night as a data scientist, especially when I'm working on real estate problems and investing my money in properties, one thing that I want to be certain of is that I'm doing everything possible to improve model accuracy. And the Feature Effects tab really allows me to see where the model is most accurate and where it's a little bit less trustworthy, right? Where its predictions might be a little bit less accurate. All right, so check this out here. What we can do is we can show, and in fact, you know what I'm going to do? I'm just going to show the actuals, right? So if I go ahead and select square footage from this menu, what you're seeing in this plot on the x-axis is, of course, the square footage of the properties. And on the y-axis, we have the model's predicted price. So not surprisingly, when we have homes with a low square footage, we have a low predicted price. As the square footage increases, that predicted price goes up. Now, what I am going to do here is I'm going to layer on the model's predictions, right? So the orange line, again, is showing actuals. When I layer on the predictions, what you can see is that that blue line is very, very close to the orange line for properties that are, less than about 5,500 square feet, right? So our model is dead accurate on the smaller homes in this data set. But as soon as we get kind of above 5,500 feet, get into these 6,000 square foot and above homes, there's some error, right? That's where a lot of the error is, the bigger homes. And another thing that you might notice here is that there's a histogram underneath this plot. This is basically showing you that we have more examples of properties in the data set that are smaller, right? So when you have homes that are kind of less than 5,500 square feet, we have more of them. There are far fewer homes that are so big, and so the model simply has less examples to learn from of these really, really big homes. So, hey, if I'm making predictions on the huge properties, maybe I will, consider some other factors before I go ahead and invest my money. Or maybe I'll actually go and take a look at the property or something. Right? So for every one of these features now, we can look and see exactly what regions the model is a little bit less accurate. And again, typically what you're going to see here is that, again, when you have fewer examples, you have less accuracy. So how do you get around that? Well, there's lots of things that you can do. Certainly one of the things you might do is just try to include more examples in your data set. And there's, again, additional feature engineering steps that you might take knowing this, right? Cool. Now, now that, we know how the model is going to perform at all these different levels, another thing that is really useful at prediction time is having an explanation for the prediction. So what DataRobot is doing here is it's actually giving us examples of high-priced homes and low-priced homes and explaining why it thinks the price should be that, right? Okay, so this curve is showing us a distribution of our model's predictions. All right, so again, most of these homes are kind of, less than $500,000, but we do have some examples of the more expensive homes. And so what we've done here is we're showing you 3 examples of high predictions and 3 examples of low predictions. All right, so if I go ahead and select this $17 million property, why does the model think that this property should fetch $17 million? Well, it's got the biggest driver here, again, was square footage. It's a 12,000 square foot property. It's got 9 bathrooms. It's on a 4.5 acre lot. So all of these values have the the effect of increasing the model prediction. So these plus signs, when we see these plus signs, it means it's driving the price up. All right, so this property here I like to look at because this is one where the images were a major factor here. Okay, so if we go ahead and select like this kitchen image here, what you can see is that this gorgeous kitchen with a massive island here is really, this photo is having the effect of increasing the value, up to $10 million. So very, very interesting to see exactly how these photos are influencing the price, and in fact, what regions of the photos are most important. And then, of course, let's go ahead and maybe pick one of these lower value homes. So what is decreasing the value of these lower value homes? Again, the text, right? Okay, so what doesn't the model like about this text? Look at amenities, bay, box, windows, double pane windows, patio. This is not a very big list of amenities when you think about those more valuable homes. This is having a negative effect here, smaller square footage, etc. So the point is that whether you are looking at a neural network or a super complex algorithm like the one that we saw here, DataRobot is going to be able to explain how that model performs, how that model behaves, and it'll be able to tell you why it thinks the price should be its prediction. Okay, so another thing that I find super interesting here is just how the system explains how it's used the images. All right, so let's go ahead and select, my favorite is really looking at the kitchen images here. So I can go ahead and select the kitchen image. And when we're looking at these kitchen images, essentially what's happening is we're plotting the image embeddings on a 2D plane. What does that mean? So remember, these pre-trained neural networks, these neural networks that have already seen lots and lots of pictures of homes and people and cars and whatnot, is being used to essentially give an opinion on what it thinks about the kitchen images. And then we're basically representing it, so the models, that neural network's opinion of the image is really just like a set of numbers, right? And we're then plotting that information on a 2D plane. And so what we see when we do that is that images that look the same appear close together. Check this out. So here's a kitchen. This is a kitchen that was worth $1.1 billion, or the house is 1.1. Beautiful cabinetry, big space and island and everything, and it looks pretty similar to these other images that are kind of nearby in the 2D plane. All right, and so what this is telling us is that what the model sees in these photos is useful. It can be useful at predicting price. All right, it's kind of coming over here. We can see again these big white kitchens with white cabinetry, right? So something about the color has was important, and probably like the open space, etc. All these kitchens have like no furniture display, lots of big open spaces. All right, great. So what I've shown so far is really a set of tools that help us understand how the model has learned from our data in order to make predictions. I've shown you how DataRobot explains its predictions, but what I have not yet shown is really how we operationalize these models. How do we actually get these models into production? And when it is time to take our model and put it into production, DataRobot really helps us out with our MLOps offering, the ability to really take this algorithm and turn it into a service that can make predictions on demand. So let's take a closer look at the deployment for this model. Now I'm going to jump over to DataRobot MLOps. What you're looking at here is a dashboard that's helping me keep track of all of the models that are under my responsibility. I've got 185 different models that my team is keeping track of, and they're all listed here on this board. Now, this is a real-time dashboard, so you'll notice that it's being updated as these models are actually processing predictions and serving them up over the network. And just in the last 7 days, these models have made almost 2 million predictions. And if we take a closer look here, we've got a couple of different key performance indicators that we are tracking, such as the model's service health. We've got one model that is actually failing here. That would be this risk management model. So if I want to quickly identify models that are failing on any of these metrics, we can just sort the board here. Service health is basically measuring whether there are any errors at prediction time. So perhaps somebody was trying to make a prediction and they didn't pass in the correct type of data, or they were missing some information that the model needed, and we can occasionally throw an error. And as the owner of the model, you can receive an email, you can receive an alert when when this happens. Some of the other metrics that we've got here are data drift and accuracy. All right, so here you can see there are 6 models on the board that are experiencing a degree of data drift that is too much. So basically, again, we can sort this board and we can see exactly which of these models are drifting. So what does this mean? Basically, what we're measuring is how data has changed since the model was trained, right? So after you train the model, there's a certain period of time where, hey, maybe the model is good and the world is continuing to be like it was at training time, but over time the market changes. As this happens, it'll be time to retrain the model. And so for each of these models, again, I will have received an alert indicating that it's time to investigate or retrain the model. And then finally, we're also measuring model accuracy over time. This indicator is telling us whether the models continue to be accurate in production. You can see that just because there is data drift doesn't necessarily mean that we'll also have a decay in accuracy. But here, for example, this parking utilization model that we have was experiencing some drift, and also we've got a decay in accuracy. Now, for today's demo, though, what I'm going to do is take a closer look at my house price predictor, which also is experiencing some data drift. So let's take a closer look. You go ahead and actually click on the model. We get a nice summary of what has been deployed here. So we have the name of the model, a little description here, where exactly it is deployed. So in this case, the model is actually deployed on DataRobot, but you should know that the models that we're monitoring here don't necessarily have to be on DataRobot. These are models that you could actually deploy in remote locations, such as on Google Cloud or on Microsoft Azure. So you can actually deploy and monitor remote models. We also have something called a portable prediction server. So again, if you didn't want to have that model deployed in a centralized place here, it is actually possible to embed your models or deploy the models in remote locations and still monitor them and report them on this single pane of glass. All right. Let's take a closer look at some of the metrics that we were discussing earlier, like that service health. So if I go ahead and now select any of these metrics, we can actually see how these models have been performing over time on a variety of different metrics. So when I'm talking about service health here, I can basically select a specific period of time that is of interest here, and this dashboard updates to show me things like how many requests were made during that period of time, what was the mean model response time, how many data errors were actually encountered. Now, one thing that I care about in today's demo is that data drift. So what I can do here is flip over to the data drift tab. So here on the data drift tab now, we have a deeper analysis of exactly why we were experiencing that red alert. On the left-hand side of the plot, what we're looking at is a set of features that are experiencing that data drift. Okay, so you can see that there's a yellow light for home exterior. You can see that the elementary school and flooring types are experiencing just a little bit of data drift here, but the thing that is really turned red is our actual prediction for price. Seems to have a slightly different distribution at prediction time compared to training time. So for any one of these features, what we can do is we can select them on the left-hand side, and now on the right-hand side, we can get a comparison of what the data looked like at training time versus what it looks like in real time as the model is actually being used. And so one of the things that is causing this feature to be flagged as yellow is that in the real world, there are new levels of this feature. What does this mean? There are new home exterior types that this model is seeing in real time that it did not see during its training period. So this is throwing a yellow flag, but really the thing that's causing it to be red is the fact that we have a slightly different distribution of our target, probably again driven by some of that data drift in our other features. So again, now I can make a decision. Do I really want to retrain the model? We can do that, right? So in fact, one thing that's really great in the platform is the ability to trigger the retraining of the model. So you can basically set up policies to manage the retraining, the automated retraining of the model. So here I've got a nightly refresh set up. So it looks like last night we had a failure of the model. So again, we get an alert if something goes wrong. Another thing I've got set up here is retraining the model based on data drift. So now the model retraining can be triggered if that data drift turns red. So basically what's going to happen here is if the data drift alert is triggered, that model is going to be retrained. In fact, what's going to happen is DataRobot, in this case, I've got the autopilot process set to run. It's going to run on quick mode. And basically when it's done, it is going to add the retrained model, not as our champion, but as a challenger model. So this kind of brings up the notion of champion versus challenger model. So when you put something in production in DataRobot, you'll have your main champion model, which is the model that's actually going to return predictions when you call your deployed endpoint. But DataRobot can also process the prediction using other models, right? Other contenders that you think might be worth evaluating, such as the retrained model that we just ran. All right. So if I jump up now to the Challengers tab, you can see that in fact this model is currently my champion. Right. This is our XGBoost model that we were looking at earlier in the demo. But we've also got some other models that we think might be good performers. There's a light GBM model. One of our stacked ensemble or blender models here is also being evaluated. And again, if as we're retraining and deploying new models, if there's drift detected, those new models basically appear on this board. This plot is showing us the average predictions from these three models over time every day as this model is making new predictions. We're basically comparing the output of the three models, and you can see that the purple model consistently has a higher prediction than the other two. And when I scroll down a little bit further here, we're also measuring the accuracy here. So low is good on this plot. This is basically a measure of error. So you can see that this purple model also has a lower error than the other two. So this is one of our challengers, and since it seems to be performing consistently so much better, I may wish to actually promote this model into production. We can do that basically just by clicking on this button and replacing the current champion with this challenger model. So basically what you have seen so far is a workflow where we trained a model in DataRobot's AutoML engine. We deployed it using DataRobot MLOps. We're monitoring this model for any issues such as service health or data drift, automatically retraining that model if there's any issues, and deploying the model and evaluating multiple challengers. I should also mention that it's possible to deploy non-DataRobot models as challengers. If you had built your own model using, Python on your laptop or some other modeling framework, you can actually deploy your own custom models to DataRobot through our model registry. In fact, you can also deploy models to the DataRobot Leaderboard and compare how your own code fares against the automatically generated blueprints by DataRobot. There is so much more that we could discuss, but so far today you've gotten kind of a high-level tour of DataRobot, where once again we focus on 4 main areas. We learned about the AI catalog, which was again an area where we can collect and organize data sets, collaborate and share those data sets. And we also saw how you can prepare data using DataRobot's new data pipelining tool. In fact, if you wanted to create very complex data preparation pipelines, you can do that. Build these Spark-powered data transformation pipelines. Finally, then we saw the leaderboard where DataRobot competed 158 different modeling approaches and landed on a really accurate house pricing model, which we then put into production using MLOps, where it can be monitored for its health and data drift, etc. It was really great having the opportunity to present with you guys today, and please join us for a Q&A session. Really looking forward to chatting with you and answering any questions that you might have about today's demo. Thank you very much.